Assalamualaikum warahmatullahi wabarakatuh. Selamat siang. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, puji syukur kepada Allah Subhanahu Wa Taala. Siang ini kita bertemu kembali di acara webinar dengan topik 3D laser scanner. Sebelumnya terima kasih, thanks to Epsilon, Boyang and Martin that already prepared their time for this webinar. Teman-teman semuanya, webinar kita siang ini sebenarnya kita akan bahas tentang NDT untuk metal. Cuma karena pembicara kita terkena COVID, pembicara di Jerman terkena COVID, jadi hari ini kita akan bahas tentang pemeriksaan geometri. Ini adalah alur kerja bagaimana proses untuk evaluasi struktur, baik itu ya ini permesinan, kebanyakan sih permesinan karena topik kita adalah NDT for metal, kebanyakan memang teman-teman permesinan, tapi struktur pada dasarnya sama. Kita perlu data geometri, kita juga perlu data mutu produk. Mutu produk diantaranya kita perlu cek dengan NDT untuk tes lapangan ya, tes uji field test ya. Juga ada tes laboratorium ya. Nah, uji geometri dan uji mutu nanti akan dievaluasi sebagai dasar untuk analisa ya. Di sini kita akan memerlukan pendekatan simulasi dan modeling untuk analisis. Nah, ini kita bicara tentang geometri. Nah, dari grup produk teknik mesin ya, dari produk Testido. Prinsipal kita Epsilon ini berbeda dengan laser scanner yang kita gunakan di sipil ya. Di sipil kita juga punya grup produk yang berbeda. Di sipil biasanya mereka men-scan infrastruktur bangunan, jalan, ada objek-objek yang besar, lalu mereka proses dengan point cloud, nanti bisa digunakan untuk pengukuran, bisa digunakan untuk nanti 3D objek produknya ya, untuk as-built drawing biasanya. Nah, di permesinan pun mirip, cuma kelebihan dari produk ini lebih fokus ke produk-produk yang kecil dan bisa digunakan untuk cek defect, quality control, dan bisa memberikan output. Dalam hal ini bisa mengaktifkan alarm, mengaktifkan nanti objek aktuator ya, aktuator bisa jadi robot, bisa jadi nanti conveyor atau yang lainnya. Nah, produk dari Epsilon ini sangat menarik karena satu sensor termasuk controller. Nah, nanti kita akan dapatkan penjelasannya dari Mr. Martin Hanis, dan mungkin teman-teman yang tertarik dengan aplikasi sipil nanti bisa kontak saya, kita bisa bikin Zoom khusus nanti terkait aplikasi sipil ya. Tapi ini memang lebih banyak aplikasinya di teknik mesin, baik di industri pabrikan, baik di tambang maupun riset dan development. Terlebih lagi ini kalau teman-teman beberapa peneliti di dosen di balai gitu ya, produk ini sangat menarik karena bisa dikembangkan dengan software yang custom, dengan software development kit. Bisa kita integrasikan dengan semacam seperti software LabVIEW dan image processing software yang lain. Oke, itu pembukaan dari saya, Zulfikri dari Business Director PT Testindo. Terima kasih teman-teman yang udah join. Mungkin next kita langsung ke acara inti. Mr. Martin Hanis akan mempresentasikan tentang 3D laser scanner. Teman-teman boleh bertanya di chat, di Q&A, nanti kita akan balas satu persatu. Dan harapan kami ini bermanfaat untuk teman-teman semuanya bisa mengambil ilmu, dan kalau perlu support penjelasan lebih detail, ada project, butuh solusi engineering, Desindo siap membantu. Okay, Mr. Martin Hanis, please start your presentation.
Okay, thank you very much. Well, yes, I will just start with the presentation. Okay. So, yeah, I think I was already introduced a little bit. My name is Martin Hanisch. I'm working for Epsilon now for 10 years, specialized in the 2D, 3D area. And in the meantime, I'm responsible for 2D, 3D measurement in East Asia. Besides, with me is also my colleague Bo Yang Liu. He will also take care a little bit about if you have questions, and will put them or will type them into the chat. He will have a look on that, and of course we will try to answer all the questions and so on. First, I will start with a little bit about the company Epsilon itself. The company itself is, come on, we are a privately owned group company with over 1,000 employees all over the world, and a consolidated turnover of about 100 and, yeah, I think this year will be about 150 million euros. Mainly focused on sensor system solutions from in the specialized area, so from tailor-made up to high volume specialized sensors. And the company, we are really engineering driven, let's talk it in that way. The headquarters itself is located in Lower Bavaria, about 200 kilometers east from Munich, next to the Austrian and Czech border. And this is also where I am sitting at the moment, and yeah, dealing with all over the world. In general, we have daughter companies in more or less all areas of the world, daughter companies or distributors. First of all, the general product portfolio is not just about 2D, 3D laser profile scanners, but also about different kind of applications and sensor technologies based on, for example, laser triangulation. Today we'll talk about the 2D laser triangulation sensors. So we also have them in one dimension. Confocal chromatic sensor systems, white light interferometers, capacitive sensors, eddy current sensors, inductive LVDT magnetoinductive sensors, draw wire sensors, and also this is the area we will talk about today: 2D, 3D laser profile sensors, 2D, 3D inspection systems, measuring systems, optical micrometers, color sensors, temperature sensors. Mainly, today we will only talk about this area, so about 2D, 3D laser profile sensors. In general, well, due to the variety of the sensor technology we'll have in our portfolio, of course, we will have also quite a lot of different kind of applications, quite a lot of different industries we are addressing, from automotive with the, of course, big German car manufacturers to aerospace, so Airbus, Boeing, Bombardier, automation, of course, heavy industries, semiconductor industries, and smartphone industry. So in general, huge variety. We are not just specialized on one kind of industry sector, but also different kind of sectors. And of course, also we are working pretty close together with universities, research institutes, and so on. Of course, we are also ISO 9001 certificated, so this is also mandatory for us to show all the documents and process and products, also shown in all our ERP system, so more or less that it's easy to see and to have an overview about the project. Besides that, we can develop and developed also according to special requirements like ethics, ultra-high vacuum, aviation, and so on. Overall, we are pretty engineer-driven, so mainly this is a benefit in our case that also sales guys in most of our cases are engineers. First, I will start with some general applications that are solved with micro epsilon sensors. Later on, we will focus on the general thing, or on the laser profile scanners. So general applications are, for example, the position measurement for the world's largest EELT mirror telescope. In this case, the mirrors need to be adjusted with a resolution in the nanometer area. So just to get more or less the mirrors that they are focusing on the detection area. And of course, they need to be extremely high temperature stable. Besides that, for example, with the inductive sensors, they are also measured continuous and non-contact. For example, with very robust sensors, they are sensitive against oil, diesel, pressure, temperature, corrosion. The bearing gap in marine diesel engines, for example, on ships. Or, for example, condition monitoring for turbines, heavy electrical equipment with eddy current and capacitive sensors. So that means that these sensors, for example, can build into the bearing directly to surveil how the ran out, for example, of this turbine will be. So this is quite a lot of, they are pretty resistant against magnetic fields and often also pretty resistant against oil, depending on the technology, also against oil, etc. Another thing that is, I think, fully equipped in the meantime with our sensors will be the flap position and the door lock control for the Airbus A350. This is really a serial sensor, and of course, due to that, we also have the approval for aviation sensors with their special needs and also special certification in this case. This is also done by us. One of our big markets is also the semiconductor industries. In this case, this is a machine of a machine builder from the Netherlands, ASML. And there they need to position the lenses and also the wafers with highest accuracy. And due to that, they are using our sensors because the optical path needs to be exactly aligned, of course. The speciality in this case will be these sensors are working in ultra-high vacuum. So that means really strong environmental condition for every sensor, and not that easy. That was for the beginning mainly the general overview, and now I will go and focus more or less on the main topic for today. Main topic for today will be gain control. This is our name for so-called laser line triangulation sensors. Yeah, the laser line triangulation sensors is two-dimensional measurement. So you're not just measure one distance, you're measuring several distances depending on the type of the sensor. More or less, the shown sensors here will have an X resolution up to 2048 points along the X-axis. So more or less, you can measure about 2048 distances. And more or less, we have two, they can be used from more or less simple setups up to very, very complex systems, but applications I will show you a little bit later. A little bit of physics to the beginning. As I told you already, we are talking about the laser line triangulation. Yeah, so a complex word, not, but in general, not that hard to not understand. You will have, in this case, you will have a laser diode. Laser diodes are, only point light sources. Then you will have an optics, and so the laser optics that will create out of the laser point, you will create a laser line. This laser line will be emitted towards the surface. On the surface, you will get a reflection. The diffuse part of the reflection will be going through the optical path, through the receiver optics, through a mirror, then on a detection matrix. So that means here you can see this one will be the laser line on the target. It is a pretty easy target, so it's more or less just a step. And this is how it will look like in raw data, the pixels directly on the matrix. And then internally, it can be calculated in that, or it will be calculated in that way, that you will have a calibration from the production side already. And with that calibration, you will get calibrated measurement results in X and Z. Our philosophy in this case will be that everything will be done on this sensor. So that means no external controller will be required, and this should be no problem. Mainly we will have, we will have two classifications. One will be the compact classification as group, let's say in that way. And the other one will be the smart classification. Compact will be to implement that into your own software environment. So you can code the software on your own. You're absolutely free to do whatever you want. Smart sensors will be mainly used for example, in the industrial environment, in the machine itself. You're not really interested in the raw data, but you're just interested, for example, in step heights, and this can be done with the so-called smart sensors. Just to give you a general overview, what we will have, what will be there, or what will be not there. Yeah. This is more or less the current overview of our measuring ranges. So you can see we have measuring range from 10 to 8 millimeters up to 200 to 300 millimeters. So in this range, we are working, of course, in this range we are working. So you can see that it's very, very small, very accurate into more or less rougher environments. For example, also to have a bigger offset in case of harsh environment. Yeah, because in this case, also with harsh environment, it will be always good to have there, for example, bigger offset just to get away from target. Mainly, most of our sensors are available in red and in blue. This has something to do with the reflectivity properties of the sensors, because more or less this is always depending what kind of material you have. In some cases red might be better, in other cases blue might be better, but this is something we can of course discuss directly on your topic, will be no problem. Now we will show you a little bit about the software that we will have. So software integration sounds a little bit boring in the beginning, but later on, of course, if you want to, I can show you where you can get the software from, and so you can play with that. For the 2D evaluation stuff, more or less, you can use the our so-called skin control configuration tools software. This is the typical solution for the smart sensors. You have the possibility to choose from several programs or predefined pre-setups, like from left to right. Here, oops. My mouse is unfortunately not causing some issues today. Here you can find, for example, an edge. You can directly calculate step height, an offset plus an angle, a gap measurement, angle measurement, middle point of a gap, and so on. So in this case, you can more or less arrange it in that way that you can directly click together your needs. You can use at the same time up to 8 programs, and you can store this directly on the sensor, as long as it will be a smart sensor. And then, for example, this sensor can directly communicate with the PLC. Yeah. So this is more or less for 2D evaluation. Another software that we are having is the so-called 3D view software. With the 3D view software, more or less, you combine, and you're doing out of the single profile software, you're combining several profiles and creating out of that a profile sequence. And this profile sequence, for example, can be then used in combination, and you can get very nice 2D 3D images, pretty images with a nice color scaling. Here in this case, for example, you can see this one is a welding application, and to show also a little bit of me, this one is just, for example, a scan of my hand. Yeah, the variety is pretty huge, and it's always depending what you will need. Besides that, in the 3D view software, you can export the data in 2D as a computer understandable grayscale image, as a PNG image, or in 3D as ASCII, STL, CSV, PLY file. The ME3D PC file is one of our own files to merge these data in future also with other internal software tools. Of course, you can also change color coding here and so on, and you can synchronize or also widthen the parts and so on. So everything like that will be possible. Of course, it is like always with our software, we cannot solve every application. On one hand, this will be a possibility because you have very complex inquiries, or you have special needs, or for example, especially in research areas, you want to have more or less you really want to work on the raw data due to scientific approval. In this case, we can provide here the SDK. So that means with the lt.dll, you can, and the SDK, you can implement the sensor with C, C++, C#, .NET, LabVIEW. We have the instrument driver, or Linux. Yeah. Of course, more or less due to the correlation, or for example, due to the similarity of different programming languages, also other languages will be possible, like Python. And of course, in this case, if you have something special, feel always free to ask, and we check how and if we can support also with other programming languages. But let's just say in that way, the integration for C family, LabVIEW, and Linux is more or less ready to use directly on the home page, and also with examples in different varieties. Another possibility is due to the fact that we are working here more or less with, you can more or less, if you have a look at the profile sequences, it is something like an image. Yeah, and due to that also we have built inside the sensor, more or less, you can think about it something like a video camera. And due to that, more or less, the scanners are also based on the GigE vision standard. The GigE vision standard is more or less common for all kind of vision application in industries. And so in this case, you can use it, and you can use this one and get more or less also implement the sensor into vision applications. This is shown, for example, in this case, you have this target here. I think it's a component of a car engine, but I'm not so sure, to be honest. You scan the whole thing, then you create such a grayscale image. Even if it looks, for example, slightly strange, this one is a 3D image. Yeah, this one is a the mentioned PNG image from the 3D view. PNG image means, or in this case, with 16-bit grayscale, the human eye is not possible to see there any distinguish, or just a rough distinguish between different kind of color codings in this case, or gray codings. But of course, the PC or the software can do something like that. And so you can do your own evaluation based on the 3D image. Now we are coming more from the theoretically background part more to applications. I will show the applications mainly in two different ways. So what kind of applications I will show? The first part will be solutions that we have solved, or applications we have solved with our skin control configuration tool software. So that means the evaluation itself was done in 2D. So every single profile will be evaluated and then, for example, transferred to a PLC. In this case, you can see, for example, this one is the application, so-called heavy edge on battery foil. More or less, you will have, in this case, this one will be the basic foil, for example, copper or something like that. And to separate the each foils in the battery production from the next foil, here, for example, some material, either dry or wet material, will be applied as a separator between the foils. And of course, you need to surveil, first of all, the height of this separator, because you need to get more or less as many foils in between the single cells to have a higher capacity. But if it's too small, you will get a shortcut, and due to that, you will get a problem in this case. This one was done with Skin Control 3000 series, 3010. Well, I skipped in this case, of course, a little bit the detailed options we will have, because I think this might be too in theory and also might be too early. Of course, we can always help there with different, or we can discuss your application later on. Yes, so in this case, rising and falling edges can be detected, and also you can see something like an overlap here in this case, and we will see. Another possibility, oh, sorry, I was in the wrong screen. So this will be more or less an overlap here in this case, can be produced or can be caused, for example, if the if it's not proper pressed in this case. In this case, here you can see a slightly different application. This one is in the wood industry for defect detection on parquet. But also I've had another customer who was also checking, for example, the dimension of this parts, and also here the sides, so that they can be used in a joint and so on. So this was used also, in this case here, just for example with the surface inspection, so to check if you have more or less the surface, and here you will have a dent on that. You can measure the depth towards the rest of the surface, so that means even if the this wooden part is moving on an conveyor belt, so it means it's jumping always a little bit up and down. The algorithms are in this case programmed that more or less you can exclude something like that. So of course you can measure, for example, if you put several point sensors here in one line, will be also possible, because a dent will mean that there is a bigger distance between that. But in this case, more or less, if you just have a point sensor, you don't know if there will be a dent or if the whole part is just shaking. This can be done with the algorithms directly in the software. Of course, you can more or less input there also okay, not okay criteria, so to get away from that. Oops, sorry. Another application will be the glue bead inspection for car windows, windshield, or backside. In this case, there of course must be applied enough glue. If there is not enough glue, the problem might be that either in the absolute worst case, the car can be unstable, because in the meantime, for modern cars, it's mandatory also for the stability to have the glass in a proper shape. Also, cracks and damage of the windows can create inverse you need applied glue. Another side effect will be, of course, if there is not enough glue applied to the windshield, that you might get a leakage. So in case of rain, water will come in with all the later on effects like rust and so on. So of course, in this case, it needs to be controlled. On the other hand, if there will be too much glue applied to that, you will have the problem that more or less it will be squeezing out, and of course will be not that nice to have a new car with a squeezed out glue, and due to that it will be checked. This is done in different applications on different productions, different car manufacturers. It is done also, well, every car manufacturer has their own procedure a little bit. So of course you can either say, okay, you can use it just for control and inspect everything. So just to say, okay, more or less we have checked everything, it will be okay. Another premium car manufacturer from Germany, for example, even record these data, and they will note it down into our data bank and store it there for the next 5 years, just in case of warranty issues, that they can say, okay, when we have built this car, here you can see after 5 years, you can still see, okay, my glue bead was 10 millimeters width and 8 millimeters high, so it was okay. So this is something like a typical application. Another application, some cases, similar to the battery foil from the algorithm side. More or less, it's about edge detection in a paper mill. So similar application from the algorithms, but different material. Here we are talking about paper. You want to see for process monitoring if more or less there will be a run out to one of the sides in case, because if the run out will be too big, you might crash the actual paper sheets there. It's a continuous paper sheet, so that means it might be a lot of effort to get the whole paper sheet new, to align the whole paper sheet in new one if it's more or less due to a crash, if this is torn apart. Yeah. So in this case, more or less, such a scan control can be used to check the movement left and right, and also to correct then very sensitive the direction, and yeah, so to keep the paper always aligned in the middle of that, and used for inline monitoring. Well, you might recognize that yeah, Germany is known for the cars, so of course there are also many applications directly in the automotive industry. And this is another example that can be done with our scanners. This will be the alignment, gap alignment of car bodies. In this case will be the gap between the driver or first passenger door and the next passenger door to keep it aligned. Can be either used just for controlling it, or what also will be possible, slightly more complex then, but also to use these data to control and to align in the production, more or less everything like that. And so could be, yeah, directly can go into the direct factory automation and how to use it, and more or less in detail. Again, an example out of the automotive industries. What will be done in this case is, looks a little bit strange here, but this one will be the part where you more or less grab the car cockpit. So that means all this part is more or less in general without the steering wheel. This will be applied or will be mounted later on, but more or less all this big thing will be mounted in one process. And due to that, the car bodies, they are on a conveyor belt, but this conveyor belt can be, yeah, depending on the production, can be in worst case, yeah, a kilometer long and so on. Due to that, more or less the position of the car is never totally even, and can be always, yeah, based with some differences in the movement forward and backward, and also sidewards. And of course, if more or less the car body itself is, let's just say, just accurate about 1 centimeter, will be highly tricky to mount there a proper to mount this in a proper way. Of course, this need to be aligned, and something like that will be done with our laser scanners, and due to that, more or less the robot will be controlled to apply it to the actual center of the car body. So this is just a rough estimation, or just a rough overview what will be possible. Of course, there will be much more possible, also with a configuration tool, so also with the 2D evaluation. Well, somehow, of course, we need to limit it somehow, also not to get too deep into everything. From our software and evaluation on the sensor head, so more or less, I will just go back, more or less, this one will be directly communicating with the PLC. Now we are going to the, either more complex applications or often research institutes will code their own software to have there also the possibility with checking all in detail and so on. So as I told you before, for example, C, C++, C#, LabVIEW, then Microsoft.NET, LabVIEW, GigE, Python, Linux. This will be an example. It was a research institute in Germany. They are they built up a climbing robot, and the problem is this robot should be used in contaminated areas, for example, radiation and so on, where it might be hard for humans to interact there. And of course, then I was not the project leader in this case, but I think with this part here, so in between the two laser lines, they are going to remove some parts here in this case. And of course, if you're milling something down, for example, of course, you should check how high you can go to avoid damage. And in this case, they have used two sensors, even if it looks slightly strange probably here in the presentation. These are two red scanners in front and after that, so to control against collision. And so, yeah, this was one of the possibilities. Another possibility that was done in this case in, I think, Romania. Of course, electronics industries is also a big topic. The criteria for inspection is getting bigger and bigger. And due to that, here they needed to check for the pin height, for pin-through technologies. So more or less, if you have PCB components that will be put through the PCB and should be soldered on the other side of the PCB. Of course, you should check if the pin is put through before you solder it. So in this case, more or less, it was done by an own specific environment, and then you can use it in this case. For example, they have written their own software. This case here, you can see again something like a computer understandable 3D grayscale image. Another application will be defect recognition on railroad tracks. Well, there are several applications in the railway industry. This one is just more or less, it isn't a real picture because unfortunately also in many cases we are not allowed to use the real pictures of the customer due to NDA or something like that. And for example, this one can be used. We had inquiries. I don't know if this was solved or not because in this case I was not the project leader. In general, it was possible to check, for example, here the washers if they are still there. Yeah. That you can also use the scan control for counting, but for other things, for example, you can also use it for inspecting the geometry of the rail itself. Often in this case, if they are really working on the field, they can go also to the higher laser class, of course, with the restrictions. For example, 3D or 3R, so that the laser has a higher intensity, and this intensity can, will be more or less a little bit less a problem for sunlight. This one will be an example for the use of the skin control in the mining industry. So what they have done here, it is used for automatic repair welding. So these are huge mining excavators that are used to dig brown coal here in Germany. And of course, for the parts are really in heavy use. So that means the usage of special components in this case are quite a lot. And before these parts are in that area that they are totally damaged, they are built, they are deconstructed in this case, put into the repair shop. Then they are scanned with laser profile scanner. It is an older application, so this one will be the laser profile scanner to create a 3D image of the current status. Yeah, so with that, they can directly recognize also in 3D how much will be worn out in this case. And the solution in this case was even more intelligent, because due to the missing volume of the material, they have directly recalculated the welding paths. So that means after scanning the part, they have directly reprogrammed the robot. So the robot was putting away the laser profile scanner and getting the welding head, and then he was starting more or less with the paths. So the green part here, this means that this is a welding track. So in this case, after scanning, they have used the welding head and welded over and over and over again until more or less the volume of the missing, there will be more volume than missing volume. And then finally, in a final, after that, most of the time they have scanned it again. So again, checking what is the current status. We have too much volume there. Again, recalculate it into 3D, compared that with a CAD model, how it should be, and then milled it down. Yeah, so this is a pretty complex solution, but will be possible. Yeah. Another similar but different application was done in one of, it's a big German research institute called Fraunhofer Gesellschaft. This thing is a PhD study. So they are going to automated workpiece processing. Sounds a little bit strange. What they're actually doing. Again, you have a welding head here in this case, and directly in front of that you will have a scan control, in this case a blue one, even if it looks slightly different. And their aim will be, for example, if you have just some parts that needs to be an additional layer for protection, for example, or something like that, or pre-shaped materials where you need to adapt even more material in some areas and so on. In this case, they are using also the scan control sensors to digitalize the surface. Then automatically the robot paths, or they are created into a 3D image. And on that 3D image, you can more or less then calculate your robot paths and start welding and creating their, for example, protection areas, or get with the single welding path more stability into that. This was done and it's pretty successful. Also, the main benefit will be, this one will be powder-based laser welding principle, and due to that, with powder-based welding, it is always slightly tricky because you might miss there some parts due to miss volume or something like that. This can be controlled and also corrected directly into the process. looks pretty similar, but more or less before that, the application before was slightly more complex because this one will be only in one direction. This is automated plasma cutting. So in this case, they also digitalize the geometry and the position of the object. In this case, it was for tanks. I think for food tanks mainly. And they have more or less digitalized the interesting area and used the position. And then due to the 3D data, the customer was able to move the plasma torch pretty accurate, so that more or less on all sides will be no problem. And here they're getting a proper and good cut. Yeah. More information, if you are interested in more applications, please visit our website. Yeah. www.micro-epsilon.com. 2D, 3D laser profile scanners, 2D, 3D / laser profile scanners / applications. Might be worth it. Yeah, because there is much more shown. It's also categorized into different applications. I will just hold on a second. I will just show it to you. (2D, 3D measurements, laser profile scanners, applications. And here you can select also towards material, towards measurement task, or towards industry area, and you will find much more applications. Yeah, for example, rubber profile, something like that. Yeah. The other possibility is, if you're interested, the software tools I showed you. So that means the skin control SDK, the skin control configuration tools, skin control 3D view, and also some, let's just say, site support software. This is also available for free on our homepage. Yeah, go to laser profile scanners software. Here it's also again described what will be possible, a little bit more in detail, other tools and so on. Besides that, you will have the possibility to download the software, and you can see more or less directly what we will be having here. You need to register mainly because we are sending you directly a download link. Without a download link will be a problem, so we will need a valid email address for this, and you can use it in this case. Another possibility will be, or just again some other references. Of course, more or less, as I told you and you've seen already, is, for example, the automotive industry with BMW, Mercedes-Benz, Volkswagen, Toyota, Honda, General Motors, but also other big car manufacturers, different kinds, and so on. So this will be no problem. In the electronics area, let's just say it in that way, here you can see Applied Materials, Apple, L3, LG, Samsung, Zeiss, ASML, or space and air industry, Bombardier, Boeing, Airbus, Rolls-Royce, heavy industries, also the big ones, and also other industries like General Electric, KUKA, Protea Automation, Bosch, Siemens, IKEA, and so on. So more or less, that was my presentation for the moment. I hope you've enjoyed it. Of course, I will now check. I saw that there were some questions. And yeah, of course, I will try to answer it. Or if you have any questions, always feel free to ask.
Ya, Bapak, terima kasih yang telah hadir ya. Ada 130 peserta Zoom webinar kita siang ini. Mungkin ada dari teman-teman yang mau bertanya langsung, kita juga jawab yang di chat. Silakan kalau ada yang mau berdiskusi, kita Martin, maybe you can answer a question and answer room live, maybe. Yeah.
Yeah, at the moment I'm already now starting from top to bottom. So
yeah, maybe
I'm just starting, or there was a or we can I can also talk about that. There was the question about non-destructive examination methods, defects on welding inspection. Will be possible. We are not specialized in that case. Yeah, so we are not specialized just in welding inspection or something like that. Please keep also in mind, I'm not totally expert in NDT testing, and I'm not the expert, especially in welding. In this case, we are not certified for, in this case, for ISO or something like that, because more or less we are something like a general, yeah, it's just general sensors. So we are not just specialized on such, yeah, we don't have the specialized approval towards ISO and so on. Please keep also in mind, in this case, the sensor is just working on the surface. So not like it was planned in the beginning with the ultrasonic inspection, where you can look inside the welding, for example, to search for cracks or holes who are inside the weld. This will be not possible with the laser scanner because we are working on reflection of laser light. And due to that, we will only stay on the top surface. The second question was there regarding reverse design engineering and manufacturing. Technical specification such as accuracy, measuring rate, volume accuracy, scanning area, measurement resolution, mesh resolution. Of course, would be possible. We have applications in this case based on different kind of materials and so on. Also, towards accuracy, it's always a little bit hard to say because this is always also depending on the kind of material, of course, of the measuring range and so on. The smallest scanner we will have, scan control 29-10/BL, will have a measuring range in X direction of mid of measuring range of 10 millimeters. I will just give me a second. I will just search for the drawing. It was somewhere. I just need to find it. So give me a second. Will be easier with the. Here we go. So this will be this sensor. In this case, you will have an X resolution of 1,280 points. So that means every point in X direction will have a point distance between these single points of 7.8 microns, and the reference resolution in Z direction will be defined as 1 micron. Of course, for example, if you go to the bigger measuring ranges with 200 to 300 millimeters, even if they have the bigger matrix in this case with 2048 points, there the resolution will be lower. Of course, it would be always nice to have biggest measuring resolution, measuring area, and highest accuracy. Unfortunately, yeah, this is always impossible. Yeah. The third question in this case was about output format. In general, it's always depending what kind you will need. What kind of sensor you want to evaluate, how you want to evaluate it afterwards. In this case, for example, with the 3D software, you can directly get the point cloud out as STL, CSV, ASCII file, and then it's up to you. So there's a huge variety, and it's up to you how to go on in this case. Unfortunately, I can only... okay. Yeah, also there was the SKF Sweden company question regarding presentation with the bearing air gap. This one is mainly not the main topic for laser profile scanners, but this is a typical topic for eddy current system.
Yes. Sorry, Martin. This question has been already answered, but there are some further questions in the chat.
Okay.
What are the advantages and the disadvantages of 2D and 3D scanners, for example?
Hard to say. Of course, every physical background has advantages, disadvantages. Yeah. Disadvantages, for example, of course, you need to keep in mind here it is not really proper shown in this case. You will always have, like every reflection, you will always have the problem with, for example, misreflections. They can happen. In our case, we are specialized on the diffuse reflection part. Why diffuse reflection? Because more or less also more shiny surfaces will have at least a diffuse part in the reflection. And for example, dull surfaces will have only diffuse parts in the reflections. So that's the reason why we are going to use the diffuse reflection. Also, due to reflectivity properties, different kind of materials can also cause different kind of reflections. Yeah, so you can compensate it in some ways, of course, but it will be also slightly hard to compensate all of that. Advantage will be, for example, towards 3D sensors. Might be also in this case that 3D sensors you will have a higher resolution in X and Y, just for example. Yeah, I'm just checking. Well, to measure, there was also the question in the chat from Aslam. I'm sorry if I don't pronounce your names wrong. Please be patient with me. I'm trying my best. To measure the thickness of tank shell. This is more or less mainly a topic for ultrasonic ultrasonic sensors, because with some of that it might be at least possible if you know about the material. With the scan control, two-dimensional scanners, you can only measure it in this case if you are more or less cut through and then measure from the side. You cannot look through the material itself. There is the question regarding bridge detection. Well, more or less, of course, you can measure also on buildings, but of course, in this case, you need to adjust it in some ways. For example, to measure just the specific spots. More or less, the measuring fields we are talking here, in this case, about millimeters and about meters. So this will be not sufficient to use such a scanner and then move, for example, for whole buildings point to point. But yeah, there are also in critical points, for example, can be used. It's not the main application, to be honest, but can be done, for example. Okay, so okay, now I will just move back to the question and answer room. There's the question from Mohammed Idris about the validation results compared to conventional methods. Always very good question, always really hard question, because it is more or less direct compensation will be impossible. Yeah. Overall, the absolute measurement, for example, in millimeter, is mainly not, is often not the main criteria. The bigger criteria, often, especially in automotive or in automation, will be always that you will get stable, reproducible results. So in this case, more or less, often, especially in comparison to other methods or conventional methods, it will be done really in this case that there will be done a comparison. So over several measurements will be directly compared, which one will be more stable and less stable. But overall, it's more or less impossible to say, okay, this one will be the only one or something like that, because different physical methods or different methods of checking that, for example, if you just go somewhere with a ruler and you might check a little bit, might be a different value and so on. So it's always hard to say what will be possible or not. Then the next question is from Suradi Santoso. I hope. Please be patient with me. I'm trying my best with names. About the inner porosity of aluminium casting. Yeah, unfortunately, we cannot look into material. Yeah. So this one will be again the speech that was planned for today was about ultrasonic sensors. Typical application in this case. This one will be a typical application for ultrasonic sensors, because with that one you can look at least a little bit into the material itself. Deniko Alisal asked about the output from scanner used by other engineering software like CATIA. Yes and no. Of course, you can indirectly, you can create CAD files that can be used in CATIA, for example. Of course, the scanner needs to be moved in an accurate way. So, of course, you need to get the single, or you need to get a movement into the part or into the scanner. Should be very accurate. Or best way will be an encoder, so that you will have always the same distance between every single profile. Then you can export it out of that, for example, with a 3D view into an STA file, and then create out of that CAD files or use that in CATIA. What is always slightly challenging, but it's possible, is more or less if you don't just have one, if you don't just scan it in one way, but you need to more or less scan several stripes, because the alignment between these stripes needs to be done afterwards, and this is not that easy, especially if you don't have marker points on that. But nevertheless, something like that can be done also with freeware software, for example, like cloud comparison or something like that. So with that one, you can more or less mash together several scans and put into different shapes, and then go for evaluate it with CATIA or whatever. Next question will be just the bridge question. I also answered that. Herdy Evendi was asking about result will be recorded in the report. It's hard to say or impossible to say. There is not just one report. There are, it's up to you. Yeah. If you will go for compact sensors, so that means only raw data delivery, then you will get an AVI file, for example, and what you will write in a report, that's up to you. Yeah. It's then based on what will be done or whatever. Yeah. Of course, for example, if you're going for a smart scanner, this one can directly output the results of the measurement, like step height, something like that. This is then also, again, a question how to set up everything. Generally, on board, the scan control can work with UDP, Ethernet, RS-422 serial communication, Modbus TCP, Modbus RTU. In combination with additional hardware, you can get it analog, digital switching outputs, or Profinet, EtherCAT, Ethernet IP. So that's a huge variety. It's always depending what you will need in this case. Then there is the question regarding detect necking process during tensile testing. Something like that was done. So it is a question how you use it, how to build it up, and so on. It is a question, the question was from Ahmad Faizin. It is always a question how to mount it. Yeah. So if the the testing normally, due to the fact that it's a dynamic process, you increase the force. 3D measurement in this case will be not possible, because keep in mind, in this case, a real 3D measurement of the whole part is not possible in this case, because more or less you will need to create a 3D image, you will need additional time, and this will be, of course, a problem for a dynamic process that is changing during the process itself. But for example, we had there some testing for metal, and I think also for plastics, tensile testing. In this case, more or less, we have moved the here in between was the target, the target, and so the strengthening was going moving forward backwards, and in this case we have placed the sensor or the laser line probably in vertical way, and so you can see more or less that then in this area where more or less the material will be breaking, you can see that there is a groove might be shaped out. This would be one possibility, or if this position is known pretty accurate, for example, in this case, you can also place the sensor in a horizontal way to see more or less the material is shrinking. Also possible. Chandra has asked for data integration, which basic database is used in this equipment. Also hard to say, because more or less it's up to you. We can provide the data. If you want to put that into a database, it is more or less a question of your database and of the implementation. Of course, you can. I'm not so sure, because this is really depending on the kind of application, and so in this case, always a little bit tricky to say if you're transferring only more or less measurement results. These measurement results can be transferred in different ways. It's always up to you. So what you actually will need, what kind of database you will have, and so on. Of course, it's always hard to tell, because I don't know about your background. For example, in universities, it's always good more or less to record, first of all, the absolute raw data as an AVI file. So we are using AVI files or video files in this case, who are coded just for us. So you don't really can see there anything proper. This can be used, and store that one, and then do an offline export, for example, as CSV, because then you will always have the raw data in the beginning, and especially for scientific work, will be always good to have the raw databases, and then later evaluate it overall. If you have evaluate that you are not in the way you wanted it in the beginning, you still have the raw data. So this is always a question. So often in this case, more or less, AVI files are stored, and then, for example, the further data handling will be done in CSV.
There was another question from Sigit regarding the software tool. Maybe we can also do a live demonstration of our software.
Yes, we can. Hold on a second.
Also, there are some hands raised up. I'm not sure. Is there any question?
Okay. Yeah. For example, what do I have here at the moment? At the moment, what I'm having here will be, I will just set back everything. I have at the moment connected to my PC a skin control 3060 minus 50. It's just 50 millimeter measuring range. And so, yeah. Okay, more or less, Iqbal Mutaquin, sorry if I spell your name wrong. Of course, you can more or less change the direction. It's always a question what you're actually doing. In general, will be possible. The direction is not fixed. Of course, you have to either move the sensor or the target. But the sensor itself doesn't care about that. What we are seeing here, this one will be the display image data. So more or less, if I'm overexposing here, this one will be my finger. Of course, for an evaluation, you will always have, want to have a straight line. Straight line is always nice. And now, for example, I'm putting in here, this is just a ruler. And more or less, you can see that there is now there's now the step here in this case. Of course, this one will be the raw data, so this one will be only in this case. Now, from the raw data, so from the raw video image of the sensor itself, here we can go to the profile itself. Well, I have not really adjusted anything at the moment. For example, in this case, we need to adjust it in a proper way, for example. Of course, there will be always some smaller changing in this case. Smaller changes and small variation will be always there, always happening. And of course, always try to get a more stable result. So you can see here, for example, just a typical edge. And now I can go for it. I haven't deleted primary parts. So I can now, for example, detect the edge step height, and also, for example, let's just go for angle between the ruler and the table. So we will use different angle. So in this case, for example, I will say, okay, I will searching for an edge. Why I've used edge left? Left means I'm using just the searching direction. Edge left means I'm searching for a direction from the left side. Choose the algorithm. I'm searching for an edge down. All the points between the two vertical lines will be used to create an average line. This one will be here, this red line. And in this case, you can see, you can set a threshold that will be parallel to that. And here we go. Here we found the edge. The edge will now have the coordinates 100 in x direction minus 2.34. And in that direction, 107. And if I'm moving that also, of course, will be changing a little bit. Yeah. To be honest, here is a groove in the ruler. This is really the way it is. So, this will be one possibility. And then, for example, also we can measure the height about that. So again, set a reference line. And here we say, okay, now we are discussing, or we are having a height difference of 3.6 millimeters. What you can see is, for example, that they are not aligned totally parallel. So that means you can see that there will be, besides the offset, there will be also a difference angle between these two lines on my table and the ruler. Pretty similar or same setup. And now you can see, for example, that they are not parallel aligned. So there will be about 1 degree difference between these parts. Yeah. There is then again the question from from SKF about 3D scanning and building information modeling for facility management during operation phase. Please keep in mind the general 3D scanning of buildings or construction site. This one will be normally done with the time of flight 3D sensor, because the measuring range will be much bigger. Yeah. I hope I understood your question in the proper way. Nevertheless, during, for example, for the construction of wind turbine towers, in this case, they are also using, there is one major application to use the profile scanners, because they are built out of concrete. And of course, for the building up process, the concrete is not really that accurate in all dimension. So that means that these concrete parts needs to be milled down to specific values, and to adjust the machine and to recheck everything of that. This can be done with the laser profile scanner. Yeah. But for, let's just say, general construction surveillance or something like that, more or less our main scanners will be much too small, because we are more thinking about microns than millimeters in general for resolution, and especially for construction, this is mainly not the main criteria. Yeah. Besides that, also, I can't show it to you now online, because I don't have a moving axis at the moment with me, so I only can show it to you offline. Especially because there was a question regarding regarding 3D applications. Please be careful. Again, the question from SKF. Atomic force microscope, confocal laser scanning microscope. We are talking about both of them are totally different technologies. They are not really comparable with laser line triangulation principle. Yeah, of course, with in this case, you can get a much higher accuracy, of course, as well as with atomic microscope, force microscope, as well as confocal laser scanning microscope. Be careful, because confocal is again different technology. Confocal chromatic is normally based on the chromatic aberration of white light on lens groups. Again, different technology. We are working here more or less on the rougher technology for triangulation principle. Benefit will be that more or less it is faster and also bigger ranges than for the microscope testing, and in automation often it will be faster, but less accuracy than microscope technologies, unfortunately. Like I told you, or I showed you in the picture, for example, this one was a scan of my hand. Still, the scanner I have used is, in this case, it was a really rough scanner. So that means about 100 millimeters, but still also for this scanner, here you can see, for example, also the hair on my hand. Yeah, so this is also a dash 100 millimeter scanner, so more or less a rougher scanner, and still you can see, for example, pretty accurate how my hand is looking like. By the way, there is really a reason why I am not scanning the other side, especially with the smaller measuring ranges. Will be always in that way that as smaller the measuring range, as higher the accuracy. Yeah. So in this case, if I would have scanned it on the other side, you would have been able directly to detect, for example, my fingerprints, and so that's why I just scanned the backside. And here you can still see the more or less also some scratches on my hand. Let's just check there. I think it was the left hand. There should have been. Yes, it was the left hand. I think so. At the moment, but I don't see my scars. Yeah, hard to say. More or less, maybe you just need to change the color coding, of course. And due to the change of the color coding, more or less, you can also make some other things visible or not visible. Yeah. So I thought I just saw an email, a question that I didn't answer yet. This one was answered, so I hope that I don't miss anything. This is answered. Otherwise, please let me know. I'm just trying to have an overview. So I'm just thought that I just saw another question, but sorry. I think I just unfortunately was nearly losing the question. Asep Mustafa was asking about the difference concept between laser scanning with an ultrasonic scanner, including data acquisition process. Please keep in mind, we are talking about totally different technologies. Ultrasonic sensors can measure, of course, distance between parts. For example, the park distance control for cars is mainly based on ultrasonic sensors. Just for general distance measurement, yeah, let's just say from our case, about a millimeter, the general distance measurement for ultrasonic will be not a bigger problem. Yeah. Benefit from ultrasonic will be always that they are pretty good against harsh environments, so more or less water they can measure through and so on. More water, dust, typical application in this case. So this will be something like for park distance. Yeah, these sensors might be exposed to water, rain, dust, and so on. So this is pretty good for ultrasonic sensors. Just mainly for distance measurement will be not that big. The second topic of ultrasonic sensors will be also then in the direction of material testing, like measuring inside weldings towards cracks and so on, different shape, yeah, totally different technology than the laser profile scanners like we are discussing it at the moment. Ultrasonic can penetrate the material. If you go for NDT testing, for example, the scanner can't. So one will be ultrasonic, or maybe ultrasonic, for also for pregnancy or for baby surveillance during pregnancy. This can be used to look inside the body. The laser profile scanner can show you, for example, a really good exact shape of the belly, but not inside that thing. So please don't mix it up. Totally different topics. Then here's the question. From Sigrid Nukroho. Well, here the scan of my hand. It was an inquiry, a general inquiry, how such scanners will behave towards organic material, human material. There are some inquiries in the medical industries to scan for meats or different kinds of meats and so on. This one was that's also why I've used more or less my parts in this case, or my hand. This was just to show how a scan of a human body part might look like. So not a specific application in this case. Nothing in detail. I think the background was a medical application, but I'm not so sure anymore, and I don't think if so, I probably would not be allowed to talk about that. Then Arjun Pratama was asking about the relation between RGB color and height in millimeters. Yes, there is. To be honest, this is more or less, of course, I can more or less adjust it. You can see here on the left side the scale of the Z coordinates. And of course, more or less, I can lower the RGB and increase the area of RGB, or I can also change that from color coding, for example, to grayscale and so on. So this is just a different kind of showing or creating there or displaying the height information. This is just a color coding. So nothing special, it's just easier to see in with colors. Hendra Hadi Praya, sorry if I did it wrong again. The direct export, no, because especially he's asking for creating a 3D data model for CATIA software from an actual part. The direct implementation of skin control is not possible. Yeah. So in this case, more or less, you need to do several steps about that. It is possible to implement it later on. Yeah, so more or less step by step. Direct implementation into CATIA will be not possible. For example, well, it doesn't make any sense in this case. Options, I can export 3D data in this case, and then I can say, okay, I can export it as ASCII file, step file, binary step file, ASCII, CSV, PLG, binary, or PLG ASCII. So in general, it will be possible, but the direct implementation in CATIA is not possible because there you will need the step in between. For example, going here through this area or through the software, record the data, and then do an afterward export. SKF is asking about the logarithmic amplifier for small reflection in context of laser scanning. To be honest, I'm not so sure what you will mean with that. Maybe you can ask it in a slightly different way. At the moment, I'm really not sure what in which direction you might mean this question. Here is still the question open from Iqbal Mutaqin about the tool or more or less use of the skin control in only one direction. No, of course you can also move the sensor in different directions or the target in different direction. In general, will be no problem in this case. So it is always just a question how to go and what to scan for that.
And I think there are two further questions not written in English language. Maybe so, Fikri, can you help us to translate these two questions, please?
Sure.
Okay, no, I was hoping for the question of Armado B, Axis Mundi, about NDT testing or virtual testing. I just used Google Translator. About the difference between NDT testing and profile testing and so on. NDT, non-destructive testing, normally will be mentioned to test, for example, the inequality of weldings and so on. This case, well, with the scanner, we are just working on the surface. For example, one of my first application I was realizing was for an NDT testing in combination with a laser profile scanner. So they have used an ultrasonic inspection head to measure the quality of welds in the nuclear power plant. And in this case, the problem will be that the ultrasonic head needs to be always pretty accurately guided through the weld, that it always will be 90 degrees towards the surface. Otherwise, you will get some disruptions in the parts. In this case, they have used the scan control sensor to more or less do the alignment of the ultrasonic head. So it can be a correlation, but we are not competing against ultrasonic heads, for example, because in this case, more or less, we are pretty different or different technologies, different topics, and so on. Scanner or our skin control will be only surface. Ultrasonic testing, normally for NDT testing, will be inside the material.
And there was another question from Herdi. Does our scanner has ISO or AWS standards or ASME standards?
At the moment, I'm not so sure in which direction this question will go. Of course, if it's just about the laser line itself, of course, we are related to an ASO standard due to laser regulation. In this case, it will be related to the ISO DIN EN 6825-1. If this is the question, I'm not so sure if this is the right answer to your question. Otherwise, just let me know.
Okay, I think if there's no further question coming up,
yeah, well, if any questions are coming up, of course, please feel always free to contact Testino, Mr. Sulfikri, or to contact me. Yeah, will be absolutely no problem. And if there are any questions, feel always free to ask. And yeah, then I would say thank you very much. And if any questions are coming up, feel always free to ask. Yes.
Yes, many participant is asking for getting your presentation. Is it possible to share the PowerPoint?
I need to check internally
Okay.
because there might be some critical parts. I need to check that internally, but I will check and maybe we'll cut out some parts, and then I will share it with you. But I need to check that how to go on. In general, I think will be possible, but yeah, I will check.
Yeah. Have you answered the question from Mr. Ahmad Faizin related with from Polytechnic Malang? What the distance about how is the scanner detects the first data to the next? Can we set the scanner to detect data within a certain period of time?
Boyang answered that. Hold on a second.
Still on the open question.
Okay. In my case, not, but I don't know.
I don't see any open question.
Yeah, there are still three open questions.
Sorry. Okay. No. I think. Well, you mean the question from Ahmad Faizan from State Polytech Malang, right?
Yes.
Okay. Optimal distance between scanner and object. Hard to say. Directly depending on the measuring range. If you have a look at the data sheet, for example, on our catalog, this will be it's directly depending on that. Smaller measuring range will be closer to the sensor, bigger measuring is far away. Of course, so there will be always the ideal area of the measuring range. It is directly mentioned in the catalog where it will be. To detect data with a certain time period, more or less you can use the scanner also to check through a specific time. The minimum internal frequency of the scanners will be 25 Hertz. So in case you want to do a long time surveillance, depending on the setup, I would recommend there an external trigger source to just get the profiles or the data in just designated time slots. In general, will be possible. Just a question how to set it up and so on. General, possible.
Another question, is there any... There's another question. Is there any relation between?
Yes, I just saw.
You see.
Yeah, now this one I saw. Application in aircraft industries. I would like to, but we have them, and many of them I'm not allowed to talk about. I'm sorry. Or at least show some details. Well, we have scanned their different kind of turbine blades as raw material, as semi-raw material, as finished material. We have detected thunder strikes on planes. We have detected small damages on fan blades. But unfortunately, I'm not really allowed to show the data because we have signed their NDA, non-disclosure agreements in this case. So I hope it's okay that I cannot really tell you there too much in detail. Yeah. In general, there is a huge variety starting from detection during the production, alignment of components in the production, also checking, for example, for the depth of rivets towards the surface. Something like that will be possible, but especially aircraft industry is always pretty restrictive, similar to medical industries, that you're not allowed to tell there too much details. Yeah, so even if I would love to tell you more in detail, mainly I'm not allowed. I'm sorry.
Yes, it is really different market, yeah. In aircraft, always with NDA. Yeah.
Well, of course, yes. Of course, Hendra, if you have it more in detail, of course we can. Or if you have a specific application, feel always free to ask. We will find a solution, and I think in a one-to-one talk, we will have different possibilities to discuss here things, but not in a bigger audience.
Yeah, yeah. Mr. Hendra is from our Nasional aero manufacturer, Martin. So the approach maybe to our friend from PTDI, the approach for special market like aero is one-to-one discussion, not in this Zoom. So please contact me or Martin.
Yes.
We will make a special discussion. So maybe similar with another customer, but we don't talk about that projects, but we talk about solution for you if you have any, you need any solution. Yeah, it is the approach for the special industry.
Right.
The next question from Mr. Agung: is there any relation between RGB color and the height millimeter?
Yeah, that was already answered. I don't know why somehow you don't see it. Yes, of course. Well, it was in the display before, or it is just the color coding. Yeah, there is a relation normally with the color coding I had before here in the 3D view software. Hold on a second, I will just show it again. Normally, if this is if I use here the colors as brighter, it was going from white till blue. As brighter it's with except yellow, it will be just a reference towards the height information, but it's just a color coding. So in this case, it's always a question. Of course, you can also use different kind of codings and so on. For example, in this case, as brighter it will be, as higher it will be, or but it's just, let's just say it's just an illustration question. So yes, there is a dependence, but yeah, always in different ways. So hard to say.
Maybe another last question. Maybe could the laser sensor use on any kind of material surface, what are the surface material limitations for both of blue and red sensor?
Mainly due to the fact that we are working with reflections. In this case, real transparent glass, for example, will be a problem. But this is from my experience. It will look different if, for example, the glass is coated. If there is a coating on the glass, the reflection properties will change quite a lot, so it will be possible. In general, you can say for organic, semi-transparent, transparent materials, blue laser line will be always better because blue from the physics has a smaller wavelength, so it will be reflected earlier than red ones. And due to that, for semi-transparent, transparent material or organic material, I would recommend blue. For other material, like normally metal or something like that in this area, red will be also fine.
Is it possible? Another question. How is limitation area for scan if customer would like to use laser scanner to and block of building chip?
I think if I get you wrong, one block of a ship will be really huge. Really huge means we are talking about meters. In this case, for example, you can there was applications in this area of shipbuilding industries to guide the robots for welding. This was a something like that, or maybe also possible to do alignment of different joints for prior welding or something like that, directly more or less to adjust during the adaptation of several blocks into one ship or something like that. This one will be not the main topic for triangulation sensors because the measuring range is too small. Yeah, we are talking about 200 millimeters measuring range in X direction, mid of measuring range maximum. I think for the big blocks of ships, if I have it right in mind, will be more or less impossible.
Okay, we have answered every question. Mungkin ada yang mau tanya langsung, satu penanya. Mungkin ada yang penasaran, pengen tanya langsung. Pak Suhendro, Pak Theodard ini ada memberikan tanda angkat tangan. Silakan aktifkan mikrofonnya kalau mau tanya, Pak. Saya bisa bantu translatekan. Pak Suhendro, Pak Theodard. Ya, Pak Theodard, Pak Suhendro. Silakan Pak Suhendro, Pak Theodard, Handoyo, kalau mau bertanya langsung. Bahasa Indonesia nggak apa-apa. Bahasa Inggris lebih baik biar langsung. Ada yang mau tanya langsung mungkin teman-teman dari DJKA, mungkin dari Balai yang ingin tanya terkait penelitiannya atau pengecekan inspeksi atau penelitian khususnya. Bisa raise hand. Bagi teman-teman dari PTDI mungkin yang nanti ingin diskusi aplikasi khusus, kita bisa bikin room khusus, nanti kontak saya aja Pak. Kita bisa undang lagi di sesi diskusi khusus. Dan tidak hanya tentang laser scanner, ada banyak aplikasi khusus ke pesawat yang telah dibuat. Juga mungkin sebagai informasi, ya salah satunya di dunia yang bisa ngukur coating, tapi materialnya material khusus ya. Di pesawat itu komposit ya, tebalnya komposit. Itu lapisan komposit, mikro Epsilon punya coating thickness meter, tapi khusus komposit. Nah itu di dunia tidak ada yang punya. Pak Suhendro, ini pertanyaannya struktur material beton. Maksudnya pertanyaannya apakah bisa diaplikasikan untuk melihat struktur material beton? Saya tanyakan ya. Mr. Martin Hanis, there is a question from Mr. Suhendro, whether we can implement laser scanner to concrete material structure.
Well, I'm not so sure if you want to put it down into into concrete or not. In general, the scanner can measure on concrete. This is in general not a bigger problem. Let me just check if I can find here that fast some examples how it will look like. No, there I don't have it. Hold on a second. In general, it will be possible to measure on concrete. Well, this will be not a big problem. It is always depending on how it will be used, what kind of material will be used. Concrete is not this. There's not just one concrete. So this will be always the question. There will be always bigger differences. How the concrete will look like and so on. So yeah, maybe I can find there some. No, I'm sorry. I think this one will be not working now. No. We have solved several applications in the concrete area. At the moment I don't have the data so fast available. In general, it will be possible to measure on concrete. Should be not a bigger problem.
Pak Theodat juga ada yang mau ditanya? Kalau enggak mungkin kita akan selesaikan acara kita. Pak Theodat ada yang mau ditanyakan? Pak Theodat? Oke. Kalau tidak ada, Martin, Boyang, all of my friends from Testindo, Harica, Epsilon, we have already answered all questions, and we hope all are satisfied with our answer and our information, and we will wait from all of you audience. If you need more detailed discussion, please contact me from email, by WhatsApp or phone call. We can arrange more detailed discussion in another time. Thank you for all of your attention and time. Martin, thank you for your presentation. Boyang, I think we are already in the end of our webinar. I would like to say thank you. Terima kasih semuanya atas partisipasinya. Demikianlah akhir webinar kita hari ini, dan kita tutup dengan salam. Assalamualaikum warahmatullahi wabarakatuh. Maybe you have the speech also, Martin?
Yes.
Closing speech, please.
Yeah. I think also thank you very much for your time. If any questions comes up, please feel always free to ask. And yeah, looking forward to go into deeper discussions about specific applications or so on. So if anything comes up, feel free to ask. And I wish you a nice afternoon.
Bye-bye.
Bye-bye.
Bye-bye.